Hi, in this video, we will discuss how to solve the noise problem by using the noise control. Almost all the acoustics situation can be described by these three elements. So for the first element, you have the noise source. Second element, you have the transmission path. Lastly, you have the receiver. If the noise source here causes undesired noise level by the receiver, in order to reduce the noise, we can apply the noise control in these three elements. For example, in terms of the source such as the human speech or the equipment, to reduce the noise, we can make these sources to be quieter. So there is a typo here, so it should be QUIET here. However, if we choose the equipment which is more noisier, or we make a louder speech, so in this case, it will cause more undesired noise. By control the noise source, then we can make the sound to be more quieter or louder. We can also control the noise through the transmission path. For example, we know the noise can be transmitted through the air, earth, or the building material. Imagine there is a traffic noise here where it is difficult for us to remove the noise sources. So in this case, we can interrupt the transmission path by building the wall to interrupt the path for the noise to reach to the residential area. You can see that the wall will cause the noise to be transmitted lesser to the residential area. By doing this, the noise can be reduced. On the other hand, if you are driving and you meet your friend on the roads there and you want to send your regards to him, so in this case, instead of closing the window, if you shout to the person when the window is closed, probably the person here cannot listen to your sound. This is because the closing window block the sound from you and transmit the sound lesser to the receiver here. So in this case, you can open the window and shout to the person. There is no interruption in the transmission path now, and the sound can transmit to the receiver here more. Therefore, we know that we can control the path in order to decide whether we want to transmit more or less the sound. Lastly, we can also control the sound on the receiver. So you can see here, receiver is not only the human, it can also be the animal or the sensitive equipment that is affected by the noise. One of the ways to control the noise on the receiver is to wear some protective equipment. Imagine that you are walking inside a workplace where you have expensive equipment such as compressor. So in this case, to control the noise within an acceptable noise limit, we can consider in three elements here. For the first strategy, we need to tackle on the source, which is the compressor here. So we can consider to change the compressor with better sound quality. So you know that compressor is not cheap. If you want to change it to a better sound quality, it might cost you a lot. Then we continue to look at the possibility to control the noise through the path. You might consider to seal the compressor with some sound absorption material so that the noise from the compressor can be transmitted lesser to the outer of the casing. However, if you have a lot of machine inside the workplace and you are not afford to do the casing for all the equipment here because this will be too high cost. So instead of do the casing for the machine, then you can consider to do casing with good sound absorption material where the receiver, so in this case the worker, can work safely inside the office that is unaffected by the machine that is operating outside there. What if there is one worker who wishes to go outside there to check the machine? In this case, we need to perform the noise control on the receiver. So we need to ask the worker to wear some protective equipment such as the earplug in order to reduce the noise exposure. In summary, in order for us to solve some noise problem, we need to consider to control the noise in terms of the source, the transmission path, as well as the receiver. So far you have learned that we can control the source. Secondly, we can control the path. And lastly, we can control the receiver in order to solve some noise problem. But what would be the best treatment? Should we focus on the source, path, or the receiver? The most cost-effective treatment in a given situation depends on the particular of the system. This is the rule of thumb to solve the noise problem. In some systems, it is easiest to tackle the source. If this is not possible, then the attention will shift to blocking or attenuating the path of the noise transmission. So if this is also not possible, then the only feasible solution might be to remove the receiver or force them to wear some hearing protective equipment. So in most of the case, it's best to focus all the three parts here to solve the noise problem. If we only consider and only concentrate on one of the elements for the noise control, so in this case, it might cause over-design. Sometimes it is even worse, where we obtain no solution if we only focus on one part. Therefore, we need to consider these three parts in order to decide what is the best treatment to solve the noise problem. Ideally, it is most effective and least costly to implement the noise control, or consider the acoustic requirement during the early stage of design, not later as an afterthought. Unfortunately, lots of machines are built with the build and hope method. In many times, noise control is not considered in the early stage of the design, and this will cause the problem. There are many reasons why the noise control is not considered. So for the first reason, it is because proper analysis and prediction may be difficult and costly, which require the experimental prototypes for verification. Furthermore, experimental studies are time-consuming and can be very expensive. Performing noise control might require a sacrifice in terms of the performance. Also, it adds the cost to the design stage. And many times we heard about the classic reason that they never had the problem before. So you can see that noise control is not considered in the design stage. Due to this reason, a lot of machines are built and hope that they have no noise problem. However, if there is any noise problem after they build the machine, it will always cost more to perform the noise control. These are the reasons why there are so many high-priced consultants remain in the business. So your aim will be to learn and to use the tools for analysis, prediction, measurement of noise. This will make you become an effective designer for the quiet machines as well as become a high-priced consultant. In this example, you see some common example for the structure-borne noise and vibration parts inside a building. Noise inside the building can be generated by the sources such as the walking noises, the traffic noise, the furniture noise, as well as some music and some falling item and the activity inside the building. Not only that, you might also have some equipment that is operating, such as the HVAC system. So you can see the airborne noise directly transmit from the machine. Also, the airborne noise can be directly transmit from the activity here. Not only that, the vibration of the machine or the activity here will transmit to more further distance through the structural path here, and you can see the vibration will transmit more and more further. Then the vibration of the wall or the floor here will radiate the airborne noise all around the building, where you can see in this picture. For the building occupants to hear better and to be more comfortable, we need to control the distracting HVAC system noise as well as other noises. The noise inside the building can be controlled by consider three elements. First element is about the sources. So we should ask ourselves whether the noise sources here can be removed or isolated. Second control strategy can be focused on the path. So in this case, we can make the wall and the floor thicker in order to reduce the noise transmission. So in the building, you can see all the occupants are staying far away from the machine that is noisy. By doing this, we are actually removing the receiver from the noisy environment. Let's try to solve the noise problem here by using the noise control strategy that you learned. In this case, you have a large hospital, and inside the hospital, you have numerous process machines such as the compressor, fans, chillers, blower, all around the building. First of all, you observe a vibration problem on a scanning electron microscope. Let's say at this floor, so the scanning electron microscope is located here, and the vibration caused the image of this SEM to be blurred. Not only that, the SEM microscope produced some annoying humming sound that is affecting the patient sleeping. Therefore, the hospital management keep on receiving the complaint from the patient. In this case, noise and vibration engineer was called to take the measurement and investigate about the noise problem here. After they performed the measurement of the vibrating microscope, they found the vibration frequency to be, let's say, 50 Hz. Then they compared this vibration frequency to the surrounding machine here, and they found the vibration frequency of the SEM microscope coincides exactly with the rotational frequency of the fan rotor of the blower, which is also equal to 50 Hz. The blower with the fan rotor of 50 Hz running speed is located at the roof, and is located 4 floors away from the SEM microscope and also the patient. So how can we solve the noise problem in this case? To solve this problem, you must be able to identify the noise source, path, and also the receiver. So in this case, we success to find the noise source to be the blower with the 50 Hz fan rotor and the corresponding electric motor, frame of this machine, and also the mounting to the ground. And from the vibration of this machine, it will transmit to the remaining building through the structure, such as the wall, floor, and also the ceiling. Therefore, this is the transmission path. The noise receiver in this case is not only the people, which is the patient that is complaining about the humming sound. In this case, the SEM microscope is also considered as the receiver because the image of the microscope is affected due to this problem. For the noise control, first of all, we can try to reduce the noise source level. One of the ways to reduce the vibration of the fan rotor is through the balancing. Balancing will be not useful if it is a structural dynamic problem where you have resonance cases. In this case, the operating frequency of the fan rotor might be matching the natural frequency of the SEM microscope. If this is the case, then you might consider to change the speed of the fan rotor to avoid the resonance. Besides that, you can also consider to perform the structural modification on the SEM microscope here. However, this option is more expensive. If the first option is not applicable, let's try to perform the noise control through the transmission path. For example, we can consider to install the tune vibration isolation mount to the blower structure here. By doing this, the vibration that is transmitted to the building structure here can be reduced. Or we can consider to move the fan to a new location where the vibration is no longer a problem. This is another option where altering of the receiving room might involve moving the patient or the microscope. However, this is not so favored because the problem still persists in this floor. Then we might consider to add the floating floor, installing the carpet, acoustic ceiling treatment, and so on that can absorb the noise and reduce the noise transmission. If these two options are not applicable, then we need to look at the receiver, which is the occupants. So in this case, we might ask them to wear the hearing protector. So you know this is not possible because it's not logic to do this. So you can see that the common sensation of the human nature is also important when we choose the possible option to control the noise.